I'm Jim Pitcher. I'm the coach for the Eaglebots, which is a 4-H team, and Ben is our president.
My name is Benjamin Lothamer. I am president of the Eaglebots, 13532 4-H.
My name is Cole. I am the secretary of the Eaglebots.
My name is Tyler, and I am a participant in the Eagle Bites, which is a sister club to the Eaglebots.
And so every year we get a new challenge where we have to design a robot to solve a game that they give us. And so last year we had 5-inch balls that we had to shoot from across the field and score in various ways. And so this was our solution for that. And each season we are not just building a robot, but we're teaching skills to all of our new members. We're doing community outreach. We have many projects that kind of go into that side of the club as well.
So just recently, a couple of our members just published a children's book that you can buy on Amazon. And we've been going to local libraries and schools and things like that and doing a reading as well as donating a copy. And they are currently actually working on a sequel to the first book. And it kind of shows that, like, it's not just about, like, building the robot or something. Like, the member that builds the book, he likes to draw and he likes to write, and so he figured that he would write a book. And so he doesn't do a lot with the building and programming side, but he does a lot with outreach, and it's a very crucial part to the club.
What's the name of the book?
The name is
Matteo and the Eagle Engineer. So as a team, we do a lot of work trying to spread knowledge about STEM and interest in STEM to the community around us. And this book is one way that we found we can reach younger students and give them a passion for STEM and teach them about the engineering design process at a much earlier age.
We made the book, and it's available for purchase. We also have displayed it at our many contests that we're going to, robotics competitions. And so we are encouraging people to buy it to learn more about the STEM process. And Eagle Bites is a sister team to Eaglebots, more focused on getting the middle schoolers more into the FTC program, and getting that we could reach more people and get more people like from a whole bunch of different middle school schools and bring them down to the Eaglebots so that we learn STEM and stuff like that at a much earlier age than high school.
Trying to create a pipeline from our outreach events into a younger club like Eagle Bites, who's going to do the exact same thing right alongside Eaglebots, led by our older members. And then those members, once they've learned the skills, will then be able to teach the new younger members, and kind of that cycle.
It's kind of like a head start to joining the Eaglebots, and it gives them like some knowledge that they can work with rather than just like showing up and like everything's new and you're just like bombarded with all these new things and you don't know what's going on.
Yeah. So this season we were given about 6 weeks to design and build a robot to not only intake balls and shoot and score them, but also a really big end game challenge where we had to put 2 robots this size vertically on top of each other in an 18-inch box. And so how we did that, which was really unique, is rather than trying to stack them, our entire robot actually tilts down into a ramp. And these components on top retract in, and that allows a second robot to drive up on us like a flatbed truck and actually kind of mount us. And that was a really innovative feature that in the entire world of over 7,000 teams, we were the only one to do that. And so at the World Championships in Houston this year, we actually were given the Innovation Award for our program. In having kind of the most unique approach to the season possible. And that's something we really pride ourselves on as a team, is not just building the best robot to score the highest, but building one that really challenges our skills and forces us to learn in a way that's really important when you're trying to get into something like engineering.
Yeah, so a lot of our parts are very custom, except for motors, gears, belts, and like screws. A lot of it is completely custom, whether that's 3D printed or CNC'd now. These side panels were once 3D printed, and then we decided to upgrade them to give it a better look and more structural, as well as they're powder coated. We actually, you want to talk about the drive?
Yeah,
And how
so our
it's-
team is pretty unique in our drive base, where because of our robots' unique sizing constraints, we only had a few inches in the back to put wheels. And so we have these dead wheels here that kind of free spin as the robot drives. And then these powered wheels, which are called swerve. And so basically, you can think of them as a powered caster wheel, where basically it's going to drive forward, backwards, but then that wheel can point in any direction we want to go. And that's something that very few teams in the world have been able to do successfully. And this is actually our second season using those in Iowa. Yeah, so that was actually a huge challenge where you can kind of see this cantilevered design, and some parts have been removed from this robot to be used throughout the summer. It's kind of gone through its full life cycle. But we have actually about 4 kilos of lead weights in the back of this robot because our drive center of mass is right here. And so we have a front axle here and a back axle there. And so it's only about 4 inches total between the wheelbase on an 18-inch cantilevered robot. So throughout about 2.5 years, we've had over 19 iterations of the drive system alone.
During the start of the match, you have 2 drivers. We usually have a driver that drives the robot around, and then I am actually the second driver. I control the intake and the arm and the flywheel, and so I can tell it to spin what's called the intake. So this will start spinning, and it has a chain. It's all direct powered by one motor, and so it'll drag the balls under here, and then it'll direct them over here to the point where it can shoot them like this.
This first stage pulls the balls in, and then the second stage here pushes the balls sideways. So we suck the balls in, pull them sideways, and then that directs them around this oval path directly into our flywheel. And so that flywheel then spins them up and over this hood, which then allows us to aim vertically.
And we can increase and decrease the speed of the flywheel for different distances, as well as we can increase and decrease the height of the hood for different distances as well.
Yeah, so really every part of our design, let me see if I can find the section here, has to be justified on why we chose that speed. And
part of an FTC requirement?
No, it's really just a more efficient way to do things. We can spend 2 or 3 days testing all the different distances, figuring out those speeds, or we can develop a kind of equation that helps calculate that for us. And so this is an example of where our members get to use the math that they learn in school, simple trig, things like that, and apply that into the robot to figure out things like how fast should this be spinning to shoot this ball this distance. And so the flywheel is a really big example of where we used math to figure out the mass of the flywheel, how fast it should spin, the angle we should shoot the ball at, and take out a lot of the guesswork from the robot to make that a very automatic process where it knows, based on this camera, it can know how far away it is from the target, and then it can automatically adjust these 2 outputs.
Yes, so there's 2 parts to the there's actually 3 parts to the match. There's the first it's 30 seconds for autonomous. So the first 30 seconds is the robots are completely autonomous. So whatever you have programmed the robot to do, it will do on its own, whether that's look with the camera or simply just move around in a certain order. The first 30 seconds is the drivers are not allowed to touch the controllers or anything, and it's just the robot. And then there gets to be the teleop period where the drivers are actually controlling the robot, and they can pick up balls, they can run defense. It's all up to them and their alliance partner, whatever they decide. They have time before the match to decide that. And then during the last 30 seconds, that's what's called endgame. So that gives you the chance to double park and get the extra points. And there's also different penalties in endgame. So the other team cannot touch our robot while we're trying to park. Otherwise, that's penalty points. And
Yeah. So it's a quite complex kind of game structure where sometimes the robots are driving themselves, other times the drivers are driving them. But then it's not just our team on the field. There's actually 4 teams. So we're against 2 and we're with a partner. And so there's a lot of partnership and strategy that goes into determining how all those teams are going to work together.
And one of you were partners for one match could be your enemy the next match. So it all depends.
Yeah, so this will take you to a link tree with all of our team's information, our website, our social media, and on our website you can learn more about our team, but then also the program. And so it's a really great program to get interested in STEM, from having no experience all the way up to really you're going to end with a college level experience and expertise in engineering.
Go check out our website, and as well as check out the book. It's a pretty good book. It's good for all ages, especially a lot of the younger ages.
Mentioned. Yeah. So, and as a 4-H team, every year we obviously have our competitions where we're competing with this robot, but then a really big part of our year is submitting that to fair and being involved on the 4-H side. And so not only getting the robot to state fair and getting a blue ribbon is a huge deal for our team, and winning receiving the Praxidyn Innovation Award here is just as valuable as any other recognitions our team has gotten. And I think FTC does a great job of kind of wrapping in a lot of 4-H values in a more STEM-based area. 4-H is really cool in that you can do anything from cattle and livestock to STEM. And so we have a thing called gracious professionalism, where every team is going to work together with each other to improve. And you're learning a lot of those personable character skills in addition to just the STEM skills.
Yeah, 4-H has played a big impact. We actually met, was it 1 or 2 other teams from, I think there's a team from Oklahoma that was another 4-H team that we met at the World Championships. But there might have been one other team, but other than that, not many teams are able to be with 4-H as well. And I think that 4-H gives us so many unique opportunities to, from like outreach to even competitions. We've held competitions at our county's fairgrounds, and it's just 4-H has given us a lot of really good opportunities and has really opened that door for us to go like one step further than teams not through 4-H.
A little story about our team. We qualified for Worlds, and this team has been together for at least 4 years.
2.
Or,
Last year
well,
was only our second season.
oh, yeah, I'm being corrected. 2 years for some of the kids, but Ben has been around for 4 or so. And what's unique about it is that the team has grown. And so I was at Worlds, and I kind of felt like a parent, and that the team was on its own and it was functioning on its own, and it didn't need me at all. And it's like a parent whose children leave to school, the nest. And so that was the unique experience about being with this team. Jim Pitcher, I'm with 4-H, and the coach and mentor. So I help with programming as well as the build. Teach business computing at Kirkwood Community College.
Okay.
And then I'm a retired radiology engineer from the University of Iowa Healthcare. So that's
That's your background.
that's my background,
Okay,
right?
great.
Talked about that a little bit earlier with the Innovation Award, but I've been with the team about 7 years now, and throughout that time we've had a lot of people graduate, and then about 3 years ago now I was actually the last remaining member on the team, and so we really had to do a lot of restructuring, and over that summer we recruited 12 new members, really rebuilt that team from scratch, and then just a year and a half later, our team, for the first time ever in over 12 years since our founding, qualified for the World Championships in Houston. So we were a top 5 team out of the nearly 300 in Iowa. And so we qualified and then went to the World Championships, where we competed, and were actually recognized with the Innovation Award for being one of the most innovative teams in the world for our program. And it's really cool to see since I've joined how much the team has grown from being a relatively small, unaccomplished team to now being one of the most accomplished teams in Iowa, and this year actually winning the First Inspire Award, which is the highest recognition you can get for a team in our program.